Let us check the first statement first. Here is the first statement. So here we have u dash. Okay, let it to be y, and you see u is a function of x. You see here u is a function of x, so y can be written as yx equal to ux into u dash x. And you know, for a function to be increasing, its differentiation with respect to x here must be positive. Let us check. Its differentiation with respect to x must not be a negative number. So let us check whether it is true or false. So y dash x will be, you know, u dash x whole square plus ux into u double dash x, and at the place of this u double dash x I will put this thing. Okay, so see what happens next. U dash x, and here then will be ux whole square by 1 plus x square. Okay, I repeat again, I have placed for this value this one given in the question, what is given in the question. Okay, so you see what we get. Here is a square. What we get, you see, this is a non-negative number because ux is a real number. You see r, that means a real number. So ux is a real number, and a square of real number is a real number. Is a real number and a non-negative real number. So this thing is, I show you in red enclosure. This is non-negative, and the denominator is a positive number. So what we have now, we have yx is equal to or greater than 0. Sorry, y dash x. Okay, y dash x, this thing. Okay, so this implies that yx is monotonically increasing function, and this means that our this first statement is true. Now I check the second statement, and for that I erase the area, this area. Okay, now I go for the second statement, and for the second statement I type in red. Here is the second statement, but in this second statement I will go for this interval. Notice that this interval I am not doing for this interval given in the question. I will go later for this interval. First I do the work for this interval. Okay, so in this interval I here use the relation given in the question. Okay, what is given in the question, you see here. Okay, in rectangular red box, and I write the same here. U dash x equals to ux by 1 plus x square. Okay, I again write the same, u double dash x equals to ux by 1 plus x square. Okay, now I now you see this thing. If you observe this thing for this interval, okay, then that will be greater than 1. Then if you remove, if I remove this thing, then there will be an inequality, and that inequality will be ux greater than u double dash x. Okay, I again repeat, I am working for this interval, not for this interval given in the second statement. Okay, I am actually I am omitting the point 0. I will later add that point. Okay, so we got this thing, and later this can be rewritten as ux minus u double dash x. Okay, let me rewrite this. Then ux minus u double dash x will be greater than 0. Okay, I will make use of this. So I numbered this inequality as 1. Now in the second side here, in this side, okay, now I rewrite the same thing. You should notice ux minus u double dash x by u double dash x will be x square. Okay, and this can again be rewritten as ux minus u double dash x by u double dash x, and you know this thing is either not 0 because I have omitted the value 0. Notice that. So x square will be positive. It will not be 0 because I have not taken the point 0 here in our case. So this is greater than 0. Okay, now see the numerator. I enclose in blue. Here you see, here you see the same thing, and this means that numerator is a positive number. Okay, now notice numerator is a positive number, and again you see the whole thing is positive here. Okay, this inequality shows that the whole right hand thing is left hand thing that is enclosed in a blue enclosure is a positive number. So what does this imply? I repeat again the same. The numerator here, the same thing here is positive. Okay, and this whole thing is positive. This implies that u double dash x, that is the denominator, should be positive. Okay, so far it is clear to you, and here we have this thing. Okay, I number it as 2. Now you see that our ux into u dash x was monotonically increasing function. Then what does it mean, monotonically increasing function? It means that if x is greater than 0, then ux u dash x will be greater than u0 and u dash 0. Okay, now notice these two values here, you see, and the same thing in the question, you see, these two are greater than 0. This means that both are positive. So from with the help of question, with the help of the relation given in the question, we can say that u dash x is greater than 0, as u0 is greater than 0, u dash 0 u dash not u dash 0 is greater than 0. So we have so far this thing is greater than 0. I number it as 3. Okay, now I again write 2 from 2 from 2 u double dash x is greater than 0. It means that, and u double dash x, if you see the question, that equals this thing. Okay, so at the place of that I can write ux by 1 plus x square greater than 0, and here you see the denominator is greater than 1 because x is greater than 0. So from this we have ux is greater than 0. So I type it as 4. Okay, now from 3 and 4, from 3 and 4, if you see 3, here is 3, here is 4. If you see these two relations, these two inequalities, then you have this one, double dash x is greater than 0, and this means that, this implies that ux is monotonically increasing. Okay, so we have proved that this function I show you in green. Okay, this function is monotonically increasing in this interval, not in this interval. So what is the difference? Difference is of a point, that point is 0. So now I go for that point, I mean x equal to 0. So I have to prove now just for one point, and that point is x equal to 0. Okay, so I erase whole thing. Okay, I have erased. Okay, now for 0 we have to work for x equal to 0. Okay, so if you see this relation, I show you in green. This relation says that u dash 0 is positive. What does it mean? It means that ux is increasing at x equal to 0. This implies that u0 plus means the value of x just greater than 0 is greater than u 0. And I have already proved that uh, this the function u is monotonically increasing in this interval, and now I prove that the function u is increasing in this interval, so in this interval. So combining these two, we can say that the function u is monotonically increasing in this interval. So okay, listen carefully. If you don't understand, then see the video again, and even if you don't understand, then mention that in the comment box. Okay.